Hello again everyone, it's Daniel here. We're going to go over questions 3 and 4 of the week 12 tutorial. These questions are about Coase Theorem, and the reason I wanted to go over them was because when I was marking the tutorial assignments, there were quite a few students who didn't quite get the idea with the answers, what you're supposed to understand. Now, I had quite a lot of students tell me what Coase Theorem was. So as you can see from the week 12 lecture slide, slide 11, the Coase Theorem is, as it says, if trade is an externality, if trade in an externality is possible and there are no transaction costs, bargaining will lead to an efficient outcome regardless of the initial allocation of property rights. So no matter who has the property rights, bargaining will lead to an efficient outcome. So I had a lot of students tell me that just repeat that definition, and that's okay, but I didn't get many students actually put it into practice correctly. And so I just wanted to go over these questions again to help you make sure you understand how does it work in practice. So let's have a look at the questions. I'm going to have it side by side. So I'm going to have questions, so that's not the right one. So I've got question 3 here and question 3 here, just so that we can have a graph as we scroll through the questions. Okay, so question 3 is talking about the operations of mining companies in extracting methane gas, and it says that it reduces the productivity of the farming properties on which they operate. Okay, so the more gas you take out, the less productive the farming property is. And the model below shows the market for methane gas, including the externality. You've got 3 curves here. The first is the demand curve. So the demand curve representing the price at which buyers are willing to pay. And you can also say, because there's no extra social benefit here, that's going to reflect the marginal social benefit, right? That demand curve is going to represent the marginal social benefit because the marginal social benefit is the same as the private benefit. So in this case, it's going to be given by the demand curve. Then you've got 2 supply curves. The lower supply curve is going to be the supply curve for the mining company, reflecting the marginal cost to the mining company of extracting methane. The marginal cost, so the marginal private cost to the mining company of extracting methane. And above that, you have the social supply curve. Well, what's that? Well, this is going to be the marginal social cost, which includes not only the cost of extracting the methane to the mining company, it also includes the external cost, the externality, being the cost to the farmers of the reduced productivity due to the methane extraction. Okay, so we've got our curves there. And part A says, what is the free market equilibrium output of methane gas? So I'm going to look at the diagram now on the right-hand side and keep the questions on the left-hand side. Free market equilibrium output of methane gas is going to be simply where the marginal private benefit equals the marginal private cost. So the marginal private benefit is just going to be this demand curve here as we had before, and the marginal private cost, as I've explained, is going to be the cost to the miners given by the supply curve. So it's going to be where the private demand and supply curves intersect, or it's going to be 20 petajoules a year is going to be the quantity at $10 a gigajoule. Okay, so that's going to be the free market equilibrium output of methane gas. And the reason that is the free market equilibrium is going to be an unregulated market where the mining companies aren't going to care about what does it matter to anybody else. So that's going to be the free market equilibrium output here. Part B asks, what is the efficient output of methane gas? And you'll remember that the efficient output is going to be where the marginal social benefit equals the marginal social cost. And here the marginal social cost is different. The marginal social benefit is going to be the same. It's going to be the demand curve. But the marginal social cost is going to be this red line up here. And so the intersection of those 2 lines is going to be where the demand curve and social supply curves intersect. It's going to be at this point here of 15 petajoules a year and $15 per gigajoule. So that's the answer to part B, the efficient output of methane gas, 15 petajoules a year and $15 per gigajoule. Part C, what is the dead weight loss from methane production in a free market? Okay, well, how do we work that out? Well, we know if this is the social supply curve and this is the demand curve, it's easy that if you can see the answer here, but how do you work it out? Well, you work it out, as you might remember from the tutorials, by looking at the difference between the socially efficient output, which is this point here, remember, and the actual output in the free market, which is going to be this point here, and looking at what happens as you move away from the socially efficient output point, which is this point here. As you move away from the socially efficient output and you get more and more and more produced, what happens is the social cost is higher and higher and higher than the social benefit, which is lower down here, right? So as you move from 15 to 20 petajoules per year away from the social equilibrium, you're going to have all this level of social cost and only this level of social benefit. So the dead weight loss is going to be that triangle formed between 20 petajoules a year, being the free market equilibrium quantity, and 15 petajoules a year, being the socially efficient quantity, and the difference between the social supply curve and the demand curve. So it's this top triangle here, obvious when you can see it, but make sure you don't have the bottom triangle there. It's not that. Okay, part D. This is where we start talking about Coase Theorem. The question says, if the farmers own the right to deny miners access to the properties, so the farmers can say, no miners, you can't come, what will be the output of methane gas if there were no transaction costs to bargaining? How would this work? Okay, and as the answer says, well, the farmers can sell the miners the right to access their land so long as they are compensated at least by the amount of the cost to them. Why is that? Why is that? Okay, well, the reason that is because you can see what the cost to the farmers is going to be if the miners produce here, but if the farmers have the right to prevent the miners to access the properties, the farmers can just say, okay, we're going to have no quantity. You're not going to be able to produce anything, right? Farmers can say that. But what happens if the farmers say that? You can't produce miners, no, you can't produce anything. The profit for the miners, if you consider what's the benefit over the cost for the miners, well, they could get this very large price up here, and the cost to them is only very small. Right? So they would all earn enormous profit if the farmers would let them mine. And what's the cost to the farmers? Well, you can see the cost to the farmers as the difference between the blue line and the red line. That's the external cost to the farmers, right? Blue line is the cost to the miners. The red line is the total cost. So the difference must be the cost to the farmers. And the cost to the farmers is not that much. Look, it's only a few dollars by the looks of it here. But the profit to the miners is very large. Here's the price they get. Here's the cost. So the profit that the miners are going to get is very large, certainly compared to the cost to the farmers. So if that were the case, the miners would say, hey, if we can produce, okay, we understand that it's going to cost you to let us mine, but if you let us mine, we're going to make a great big profit. So how about we pay you the cost so that you can let us mine and get the profit? So what will happen is the miners will be prepared to pay the farmers their cost, right? The miners will be prepared to pay the farmers their cost until the cost to the farmers is exactly the same as the profit that the miners would make, right? So at this point here, at the socially efficient quantity of 15 petajoules per year, the cost to the miners, the cost to the farmers is $15 a gigajoule minus $7.50. That's $7.50 is the cost to the farmers. The cost to the miners is also $7.50, right? So at that price there, the miners are going to get $15 per gigajoule from selling it, and they're going to have costs of $15 per gigajoule as well. $7.50 of their own costs and $7.50 to pay the farmers. Anything more than that, the cost to the farmers and the miners together is going to be higher than the amount of money the miner could receive. So the miner isn't going to pay for any more. Right? The miner isn't going to pay to produce any more, because if, for example, they wanted to produce 20 petajoules per year, well, what's the cost to the miner going to be? It's going to be their own cost plus the cost to the farmers. What price can they get? Only this price down here from the demand curve. Well, that's not worth their time, right? They're actually going to lose money if they do that. So they'll only be prepared to pay the farmers up to the socially efficient quantity, being the point where the price that they can receive is equal to their own costs plus the cost it's going to pay the farmers for the external cost, right? The cost to the farmers. Anything less than that, and still the profit that they're going to receive from producing is going to be more than the cost to them plus the cost of paying off the farmers. So they will have an incentive to pay the farmers until the socially efficient quantity of 15 and a price of $15 per gigajoule. So if they charge the miner the marginal external cost, if the farmers charge the miners the marginal external cost, then the miners will pay them to produce until it gets to the socially efficient quantity of 15, after which point it's not worth their while anymore to pay anymore because they're going to make a loss. But part E, so that's the answer to part D. If the farmers have the right to deny miners access to the properties, then in that case, the miners will pay them to access the properties until the socially efficient quantity, at which point it's not worth the miners paying them anymore. But part E says, would it matter in theory if instead the miners had the right to drill on the farmers' properties? Why or why not? And yes, I got a lot of students telling me, okay, well, Coase Theorem says it doesn't matter who has the property, but you didn't really explain. It was very rare that students explained what did that actually mean in practice. And I'll tell you what it actually means in practice. If it is the miners who start with the property rights, the miners, I suppose they could produce 20 petajoules per year, right? This is their demand curve, this is their supply curve, so this is their equilibrium point. They could produce here, but they're not going to if the farmers can still trade. Why? Why won't they produce here? Because if the farmers can still trade, the farmers will say, hey, look, actually, if you produce 20 petajoules a year, look, there's a very large external cost for each extra unit that you're producing, right? This is the extra cost to us, $10. Whereas for you, you receive $10, it costs you $10, doesn't really make any money for you. So how about the farmers pay the miners? The farmers say, how about we pay you not to make so much? How about we pay you not to make so much, right? It's going to cost us this much, you get basically nothing, right? How about we pay you? And so what will happen is the farmers will pay the miners not to produce. The farmers will pay the miners not to produce so much, all right? But how much? Well, the farmers will pay the miners not to produce until the cost until the profit that the miners would make is equal to the cost to the farmers, right? The farmers aren't going to pay the miners not to produce down here because at these quantities, look, the miners are going to make a huge profit to produce. Cost to the farmers is only very small. Farmers isn't not worth their while to pay the cost to the miners of this much if it only costs them actually this much themselves. So they're not going to pay the miners down there. They're only going to pay the miners up to the point at which the cost to the farmers is the same as the profit that the miners would make from that extra marginal unit, right? Anything more and the cost to the farmers is more than the profit to the miners if they made it, so they'll pay them to make less, but anything less and the profit to the miners, which is this difference here, is going to be more than the cost to the farmers, which is this difference here. So that is too much for the farmers to pay. They're not going to pay that. So they're not going to pay anything to the left of this point. They'll keep paying to reduce it from the right of this point. So even if the miners have the property rights, still the quantity that will be produced is going to be 15 petajoules a year, the socially efficient quantity, because they can trade and there's no transaction costs, as Coase theory suggests. So that's the reason why it wouldn't matter in theory, because in this situation then the farmers would pay the miners not to produce so much. Okay, let's have a look at the last question, question 4. Question 4, let's go. Okay, so it's got draw the paper mill's private supply curve, the social supply curve, and the demand curve for paper. Okay, this is a fairly simple diagram. You've got the marginal cost for the paper mill, the cod farmer's marginal cost for pollution. All you really have to do here is plot those points, but making sure that the social supply curve, when you plot the points, is equal to the private marginal cost for the paper mill plus the private marginal cost for the cod farmers. So that's going to get you the social supply curve. That's going to get you the social supply curve if you add those two private supply curves together. Okay, so part B asks what is the efficient level of paper production if no one owns the lake and there is no regulation of pollution. What is the quantity of paper produced per week? So you can see what's happening is the paper is dumping waste into a lake used by the fishermen, right? The paper mill's dumping waste into pollution into the lake, and so no one owns the lake and there's no regulation. What's the quantity of paper produced per week? Well, in that case, the efficient level of paper production is going to be where the social supply curve equals the demand curve. In other words, the marginal social benefit equals the marginal social cost. And that's going to be, if here's the social supply curve and here's the demand curve, that's going to be at this point here a quantity of 30 tons of paper per week, 30 tons of paper a week. And it looks like at $35 per ton, something like that. That's right. And if no one owns the lake and there is no regulation of pollution, the quantity of paper produced per week isn't going to be that, because the paper people are going to say, hey, well, it doesn't matter to us. The pollution doesn't really bother us. What matters to us is we want to make maximum profit. So we're going to produce at the point where the demand curve, the marginal benefit to us, equals our supply curve, the marginal cost to us, right? So we're going to produce at this point here 40 tons of paper per month, I think, or week, sorry, 40 tons of paper per week. That's where we're going to produce, 40 tons of paper per week. And so it then says illustrate the deadweight loss in your figure. Okay, now as I said a moment ago, the way you do this is to compare the position from the socially efficient output point, which was here, 30, and where you're actually going to produce, which is going to be at 40, and look at what happens when you produce that extra amount. Well, if we produced 40 instead of 30, then the cost to society is going to be higher and higher and higher, and the benefit to society is going to be lower and lower and lower. So the deadweight loss is going to be the difference between the cost to society and the benefit to society of that extra 10 units. So this grey triangle is going to be the deadweight loss. Okay, so part C asks, if the government introduces a tax to achieve the efficient quantity of production, what is the tax per tonne of paper produced that achieves an efficient outcome? And as the answer suggests here, the tax that you need to have is going to be the tax that equals the marginal external cost. You need to have a tax where you need to have a tax so that the paper mill's private supply curve is going to intersect the demand curve at the same point as where the social supply curve had been intersecting. So we're going to need the private supply curve to intersect the demand curve at 30 tons a week in order to get that efficient quantity, in order to produce that amount. So what do we need to do? Well, what we are going to need to do is look at the difference between those 2 points. Look at the difference between those 2 points at the efficient quantity, and the difference looks like it's 15, and put a tax that is equal to the difference. So you move this private supply curve up by 15, and you're going to get another supply curve that looks like this, and it's going to intersect at this point here, giving you the socially efficient quantity, right? So the difference at 30 is $15 per tonne, and that's the tax that you're going to need to get an efficient quantity of 30. Notice that the slope of the curve is different, and you might have said that maybe we should put in a tax of $20, right? See, here's the social supply curve. That's going to have $45 a tonne. Here, there's a gap of $20 a tonne. Maybe we should put a tax of $20 a tonne. But that's not going to lead you to the right answer. If you say $20 a tonne is the tax, that's going to be wrong. Because if you move up this private supply curve up $20, you're going to have a different curve intersecting somewhere here. You're not going to intersect at 30 tonnes a week. You need to move it up by the amount that it takes to get the private supply curve to the same intersection point as the social supply curve. And that amount is going to be $15 a tonne, because that's the difference at this socially efficient quantity. Okay, so that's the answer to part C, $15 per tonne. Now, part D. If the cod farmer owns the lake, so the fishermen own the lake, and there are no costs or impediments to bargaining, how much paper is produced per week, and what does the paper mill pay the farmer per tonne? And explain your answer. Now, many students got this right, and the correct answer is to say, well, if the cod farmer owns the lake, they're not going to say, no, you can't make any paper. Right? They're not going to say, no, you can't make any paper, because the paper people are going to say, well, hang on a minute. If you let us make paper, look at all this profit we can make. It only costs you this much, right? How about we pay you what it costs you? How about we pay you what it costs you so that we can make paper? And they're going to continue to pay the farmers what it costs them until there's no more profit to be made by the paper mill, which is going to occur at a quantity of 30 tonnes of paper per week. They're not going to pay for more than 30 tonnes of paper a week, right? If they're going to, for example, at 40 tonnes of paper a week, or at 35 tonnes of paper a week, say, well, how much is it going to cost them to make that much? Well, it's going to cost them this much anyway just to make the paper. But then they're also going to have to pay this additional amount, which is what it's going to cost the farmers. It's going to cost the farmers this additional amount. And what price do they get for their paper? Well, only this much. So it's not going to be worth their time to do that. They're not going to pay the farmers at quantities above 30, because the amount that they're going to have to pay the farmers to get them to accept is going to be more than they can receive in the price. So they're not going to do that. But part E is the key point. Even though it's only worth 1 mark in this question, it's a key point for understanding. I want to make sure that you understand it. The question says, if the paper mill owns the lake, so the paper mill themselves own the lake, and there are no costs or impediments to bargaining, how much paper is produced per week? Now, if the paper mill owns the lake, I got a lot of students telling me, well, hey, if the paper mill owns the lake, well, they don't have to care about the farmers, right? It's true, they don't have to care about the farmers. But a lot of students said, well, they're going to produce at 40 tonnes of paper per week. That's not correct. They're not going to produce at 40 tonnes of paper per week. Why is that? Why aren't they? Well, you might say, hey, that seems a logical amount. The private benefit to them, that's 40. They want to produce at the point that it equals the marginal private cost to them, right? So that's $25 a tonne is both the marginal private cost and the benefit to them. You might say, why aren't they going to produce there? Well, the reason is that the fishermen are going to say, well, hey, hang on a minute. You're getting $25 per tonne for the extra unit. You're paying $25 a tonne. So you're basically making nothing. But it costs us $20 a tonne, even though you make nothing. How about we pay you a little bit to make less? How about we pay you a little bit? See, it's costing us $20 a tonne. That's a lot. How about we pay you some of that and you can make less so it doesn't cost us so much? And the fishermen will continue to pay the farmers until the point at which the amount that the fishermen are going to have to pay, so until the socially efficient quantity, because beyond the socially efficient quantity, the amount that the fishermen are going to have to pay, which is what the profit that the paper mill would make, the difference between the demand curve and their supply curve, that profit is more than the cost to the fishermen, right? So why would the fishermen pay the mine all this money if the cost to them is less? They're not going to pay all this money. They're not going to do that. They're only going to pay to the point at which the cost to the fishermen is equal to the profit that the paper mill would make, the profit that the paper mill would make, and no more. They're not going to pay to reduce the quantity by any more than that, right? They're not going to pay any more. So notice that previously we had an equilibrium point where previously the farmer owns the lake, and the farmer was going to say, okay, or rather the miners were going to say, okay, you guys own the lake, but don't let us produce something, right? The cost to you is only very small. The profit to us is very large. How about we pay you until the cost of paying you is equal to the profit that we would make? That's going to lead to the socially efficient quantity of 30 tons per week. Now, in part E, if the paper mill owns the lake, this time you still get 30 tons per week being produced, not 40, still 30 tons per week being produced, but this time it's the farmers who pay. It's the farmers who say, hey, don't make so much. You're not going to make that much profit anyway. How about we pay you what it's going to cost you until until we can't afford it anymore, which is going to be at 30 tons per week, right? If it's more than 30 tons per week, then what's going to happen? Well, how much is the paper mill going to make? Well, they're going to make this price from the demand curve less their private supply curve, so only a small profit. But the cost to the farmers is this much. It's a larger amount. So the farmers are going to be happy to pay, right? Farmers are going to be happy to pay until you get to the socially efficient quantity, because beyond the socially efficient quantity, the amount that the paper mill would make is this much, right? The difference between the demand curve and the private supply curve, that's the profit they're going to make. And the marginal cost to the farmers is only this much, this externality. So they're not going to pay this large difference to only reduce their cost by this much. Doesn't make sense. So they are going to pay the paper mill to produce less until you get to the socially efficient quantity of 30 tons as well, right? Until you get to the socially efficient quantity of 30 tons as well. So the reason that the quantities of paper produced in both D and E is the same is because the Coase theorem applies. Because in part D, if there are no transaction costs and they're free to trade the externality, and the farmers own the lake, well, the miners are going to pay them, or not the miners, the paper mill is going to pay them to produce, so they can produce. They're going to pay them the cost. The paper mill is going to pay the farmers the cost to the farmers, so that they can make their profit. If the paper mill owns the lake, the farmers are going to pay the paper mill their lost profits, so it doesn't cost the farmers so much, right? It's easier for them to pay the paper mill not to produce than to accept this very large costs. So that's the reason why the quantities of paper produced are the same. In one situation, the miners, if the farmers own the lake, the paper mill is going to pay the farmers to produce, and if the paper mill owns the lake, the farmers are going to pay the paper mill to produce less. Okay, that's all for Coase theorem. Please let me know if you have any questions, and good luck in your exam. Thank you.